So example 2. Now, I've already got everything labeled as far as how we're going to factor this, but let's just go through each one of these. Let's read the question first. 3x minus 3x squared over x squared plus 4x minus 5 times x squared plus x minus 20 over 3x. So on the top left, we're going to be pulling out a GCF. What would that be? 3x. The bottom, we're using the x method because it's 3 terms. The top right, x method, 3 terms. Bottom right, can't do much with 3x, right? It's just a single term, so just going to leave it that way. All right, so the top left's pretty easy, right? It's going to be 3x, and you'll be left with 1 minus x, I think. Yeah. Bottom left, let's go ahead. Let's look at both of these x methods. We can do them both, right? So next slide, we'll have both of those. On this one, you'll have negative 5 on the top and 4 on the bottom. On this one, you'll have negative 20 on the top and 1 on the bottom. I'm going to go ahead and teach you guys a shortcut that you might not have picked up on. Maybe you have. And here's the key to the shortcut. Can everybody see that the coefficient of the x squared is 1? When that happens, if and only if that happens, you can use the following shortcut for the x method.
Wait, what did you just say?
What I said was you can use this shortcut as long as the coefficient of x squared is 1. And so here's the shortcut. When I form my x, okay, so 5 times negative 1 is negative 5. 5 plus negative 1 is 4. This is actually going to give you the factorization. It's going to be x plus 5x minus 1 when the coefficient is 1. Same thing for the right. 5 times negative 4 is negative 20. 5 plus negative 4 is 1. Since the leading coefficient x squared is 1, the factorization is going to be x plus 5x minus 4. Okay, but if the coefficient was 2 or 3 or even negative 1, it doesn't work. So just be careful when you use it. You can't just assume that works. You've got to look at that leading coefficient and make sure basically there's nothing there. So that means that this particular expression is just going to become x plus 5x minus 1, and the one on the top right will be x plus 5x minus 4, and it'll look like that. So in other words, you're skipping the part where you have to break it down, right, and then pull out a GCF. And then again, the top left we used by pulling out a GCF. That's how we got there. All right, so that's step 1, completely factor everything. You know this next step is to cancel. What do you notice will cancel from here? The x plus 5s will cancel, so that one and that one. The 3x's.
That's it.
That's it for now. I'm going to teach you another little trick.
I'm scared.
All right, so the 3x's will cancel. The x plus 5s will cancel. And we have this. Are there any... So let me read this. 1 minus x times x minus 4 over x minus 1. Is there anything in there that looks similar? Yeah, 1 minus x and x minus 1. I'm going to start with just numbers, and I want you guys to pick out a pattern and relate 1 minus x to x minus 1. So let's do a new page. On the left, I'm going to write 1 minus x. On the right, I'm going to write x minus 1. So I teach this, you know, I've always taught this. I used this when I was younger. If you want to figure out a rule in math, sometimes you plug in numbers for a variable. So let's pick a number for x. What do you guys want to pick for x? 2. Okay. If I plug in 2 for x on the left, I get negative 1, right? If I plug in 2 for x on the right, 2 minus 1, I get positive 1. So on the left I got a negative, on the right I got a positive. Let's pick a different number for x. What else would you like to plug in?
6.
Good number. Let's plug in 6 for x. And so instead of 1 minus x, we're going to put a 6. What is 1 minus 6? Negative 5. And on the right, 6 minus 1 is positive 5. What's the pattern that we see emerging? One is what and one is? One's negative, one is positive. In general, So if I take this number and divide by that number, that'd be the 1 minus x divided by 1 plus x, I would get what?
1.
Negative 1. Okay? Oh, great question. If you did 1, it would be undefined because you have 0 on the bottom. Right? You can't do 0 over 0. But for any other number, that is correct. Good point. So here's ultimately, I'm going to explain the algebra behind that. So the top we had 1 minus x. Let's pull out a negative 1. The positive 1 is going to change to negative 1, and the negative x is going to change to positive x. You can pull out a negative 1 out of any expression. All it does is it flips the signs on the inside. The second thing we're going to do is going to switch x and negative 1 using the commutative property. And so it becomes x minus 1. And now you can see they cancel, and you can kind of see that confirms what we just showed. It's going to give you negative 1. 1 minus x over x minus 1 gives you negative 1, no matter what number you plug in, except for, like she said, 1. So those will cancel, and you're left with negative 1 times x minus 4. So this particular one, sometimes the fraction goes away when everything on the bottom cancels. So how would you simplify from there? And by the way, we actually found this out yesterday. I never really thought about this, but that rule works. It actually doesn't matter what the number is. It doesn't matter what the number is. It could actually be, let's say, 7 minus x over x minus 7. I'll go back to it in a second. So hold on. So instead of 1, you can put any number there. You're still going to get negative 1 back, because the top is going to be negative whatever, right? And the bottom is going to be the positive version of that. So it works for any number. Pretty interesting rule. Okay, so we get, let's go back to that. We get negative 1 times x minus 4. What would that simplify to? What would you do with the negative 1? Distribute it, right. So it's going to become negative x plus 4. And the last thing I would do, if you have a negative and then a positive, negative variable, positive number, put the number first. So it just becomes 4 minus x. And that's it for this one, because there is no denominator to multiply out. So sometimes your answer is not a fraction. Okay? We are going to do one more.
Can you go back to the last page?
Yes.